Hello and welcome to the YouTube Aztec channel. That's the Azure Technology channel. My name is Neil Millington and I'm a Cloud Solution Architect at Microsoft. And we're going to be talking today about SQL Server Graph databases, which were introduced in SQL Server 2017. And I'm also going to be touching on Power BI, whereby we're going to be using Power BI as a way of graphically visualizing our graph databases, which are stored inside SQL Server. And as you can see here, as it mentioned on that slide, we're going to be talking, this video is pitched at level 300, and that level is using the Microsoft classification for training. As you can see here, there are 4 levels, level 100 through to 400. Basically level 100 is very high level PowerPoint based material, for example, and assumes that you have very little knowledge of the subject matter. Level 400 is classed as an expert, very detailed material. And we're pitching at level 300 here. So level 300 assumes a basic understanding of the subject matter or the principles that we're talking about. So in this case, there are 2 prerequisites. And the first one of those is, again, this is all particular to SQL Server, need you to have an understanding of database principles and objects. So in particular, need you to understand SQL Server tables and views. And as a result of that, I also need you to have an understanding of SQL Server, the SQL language, and CSQL. And in particular, I'm going to be using select, join, and insert commands. And the tools we're going to be using in this video are, obviously, I've installed a copy of SQL Server 2017. I have the Power BI desktop also installed, and I have downloaded a custom visualization called Force Graph, which we'll touch on that in a short while in the video as well. So, SQL Graph inside SQL Server. What we have here is a high-level architectural diagram of how the graph database has been introduced inside SQL Server. So working top down, we have the database or a database itself, and that contains your graph database and obviously the graph data. A graph database is a collection of, there are 2 main table types inside the SQL Server implementation. That's a node table, which you will also see or hear them referred to as vertices tables. I'm actually just going to be talking node tables here. And you also have an edge table. So a node table is effectively your main data entity. So for example, that could be a people entity, an address entity, or a car manufacturer or a car model. And an edge table is basically a table that holds the data which describes the link or relationship between one or more of the node tables. So for example, for family data, the edge table, which is one of the examples we're just about to touch on, the edge table could refer to the relationship between 2 people or the address that a person lives at, for example. And as I said, we'll have an example of that in a moment. So both table types, whether they're node or edge, you can have a property. So for a node table, a property could be, for example, if it's a person, their gender or the date of birth, and a property for an edge table, a link or relationship between nodes, so particular again to people, that could be their relationship, i.e. father, mother, son or daughter. So that said, let's actually get into SQL Server and start looking at a graph database and the data therein. So here I have my SSMS even, and as you can see, we've got 2 tabs open. So we have 2 sets of data that we'll be using today. On this tab I have, as I mentioned earlier, we have some family data, which I'll explain momentarily. And then on this tab I have a subset of some of the London Underground or the Tube data. And these 2 tabs correlate directly to 2 databases that I've set up on. I have a SQL PAS instance running here, which is obviously SQL 2017. So I have 2 databases. I have SQL Graph, and that contains this graph family data here. And I also have a SQL Graph TFL Transport for London, and the TFL database holds the London Underground, the TFL related data. So going back to the SQL Graph, the family database, the way the Graph database has been implemented in SQL Server, as you can see here within SSMS, we have one folder called Graph Tables, and this is where all of our graph specific objects are held. And if you remember, we have two table types. We have a node and an edge. So in the family data, we have two nodes. We have people and addresses, and as you can see, both these are represented by the icon with the little blue dot. And we have four edge tables. Remember, an edge is a link or a relationship. We have children, home address, parents, and siblings. And I'll explain those momentarily. We'll populate some data so you can get contextually, it'll start to make sense what we're doing here. So as you can see, those the graph tables are held in their own folder. And what I have here as an example, I can just to show you, we also have a standard DBO schema-based table. And what that allows us to do is you can still have your standard relationship objects, tables, or views inside a database, as well as your graph tables. And it does allow you to cross-join data if you so choose. So you do need to watch your naming convention there. So you need to basically your table names need to be unique in that context. But as you can see here, you can have graph databases, as I've mentioned, alongside standard relational databases. So let's get going with the actual family data. And again, summarize: two node tables, address and people, and four edge tables: home address, parents, children, and siblings. And we will keep referring back to these during the course of it. So we're going to insert some data. So we're going to populate the people table first, and we have 5 people here. So basically the structure of the people table is pretty basic. We have a person ID, a name, and an email. I've inserted those 5 people, and now we'll populate the address table. And again, for speed, we've just got 2 addresses here. So we have my house with that postcode and my flat with this postcode. So what I want to do, the main context of this is, let's start to populate our edge table. So the first one is called home address. And I've hard-coded these values rather than using cursors, or, for example, which is what we do in an actual production-related graph database. So I've actually hard-coded these values so I can explain it, and you can start to see the way you build up your graph database, and in particular the edge link relationship tables. So what I'm doing here is I'm inserting values into home address. And what we're saying is we link, basically the way an edge table works is it links, as I mentioned, node table data. So it links a node data item to a data item in another node, so to speak. So what we're doing here is, as you can see, I have I'm selecting the node ID, which I'll explain this $node ID momentarily. I'm selecting the node ID from my address table where the address is 2. So in this case, the address is my flat. And then the next column in the home address, I'm then selecting the node ID from the people table where the person is person ID 4. Person ID 4 is Jane Williams. And basically what we're saying is the relationship, or remember the property, is own flats. So to summarize, we're basically saying for my flat at RG11, it's actually owned by person ID 4, which is Jane Williams. So in that edge table, that would be our first row of data. So Jane owns that address. And again, just to talk you through the next example, we are then selecting the node ID from address where the address type is 1. So this time it's the address type is 1, my house with that postcode. And we're selecting the node ID from people where the person ID is 1. So the person ID 1 up here is Bert Williams. So basically what we're saying then is the property of that is owns house. So effectively what we're saying, so for address 1, my house, Bert, person 1 is the owner. And then we have 3 more relationships. Again, they're all, as you can see here, related to address 1. So for my house, person ID 0, 2, and 3 all live at. They all have the property lives at that address. So basically what we're saying there is Debbie, Rob and Tina all live at address 1. So let me insert those 5 rows into the home address. And there we go. So basically what we have now is we have 2 populated node tables and 1 populated edge table. And again, I'm going to start to speed this up because there's quite a bit here. We can actually do this during a hands-on lab. There'll be a GitHub link later on for you to download and run through all of this yourself. So we now have a parents table, and it's the same principle as above with the home address edge table. So we're going to populate the parents edge table. And again, as I described, the idea of the edge tables, it describes the link, it describes the relationship between nodes. So what we're going to be doing here, as you can see, the properties are mother and father. And basically what we're saying here, as you can see, so the link between person ID 0 for person ID 2, 3 and 4 is the mother. And down here we're going to be saying the link, the edges, the edge table entries for person ID 1 is going to be the property is father for persons ID 2, 3 and 4. So basically if we refer back to our person table again, so effectively what we're saying is Debbie, person ID 0, Bert, person ID 1. So effectively what we're saying is Debbie is the mother of 2, 3 and 4, and Bert is the father. So we'll run those in, populate that table, populate that parents edge table with those 5 data items. There we go. One more, children, same principle. I'll start, as I said, I'll start to speed this up. So we're saying person ID 2, 3 and 4. And then we're releasing these back to, linking these back to, person ID 0, which remember is Debbie the mother. So basically saying person 2, 3 and 4 is the son or the daughter of person ID 0, which is Debbie in this case. And again, we're repeating that. So we're saying person ID 2, 3 and 4 for person ID 1 is the son and daughter. So remember, so basically person ID 0 was the mother, person ID 1 was the father. So that is our children edge table, which I'll populate there. And let's all bring this into context. How do we query our graph data inside SQL Server? So anyone who's familiar with the Cypher language, the current implementation of SQL Server Graph is, as I mentioned, it came out in SQL 2017, and it's the first iteration of graph databases. So there's a limitation to some of the languages, or some of the language that is supported here. So what we have initially is we have this match command. So match, as I just mentioned, then comes from the Cypher language, if anyone's familiar with that. And basically match works on a principle of joining a node table to another node table via an edge table. And to try and make that contextually more simplistic, basically the match command means we join a data entity via a relationship to another data entity. So let me walk you through the first set of SQL commands here. So as you can see, this is all relatively straightforward select command, the only real difference being this match syntax we have here. So we're selecting these columns from these tables where the match is as follows. So as you can see, in terms of the from, I have the people table. Remember that has the 5 people in it. And I've aliased that as parent standard SQL. I then also have a children table. So remember, children is the edge table we've just populated. And again, I've also referenced, or I'm also using the people table again, and this time I'm aliasing it as child. So in terms of this match command here, we're basically saying we want you to match the child with children to get to the parent. So basically using the child node table, I'm going to use the children edge link table to then determine who their parent is. And that's simplistically what that means. So in terms of our select command, we're basically saying from child I want the name, and we're going to call that column child. Again, we're just using an alias there, standard SQL. And then from children I want the relation. So again, to put this into context, the relation is, for example here, son or daughter. And again, I'm selecting from the parent table the name, and I want to actually select that as a parent. So if I just run that so this starts to make sense, what does that actually give us? So here, down here, we have the results. So what we're saying is child, Rob Williams, in terms of what's his relationship. So Rob is the son of Debbie. Debbie is the parent. So basically the child column, the relationship, and then the parent. And this repeats through. So basically this translates to person ID 2, 3, and 4. So basically what we're saying there, here's our child node, here's our children relation, and here's our parent node's worth of data. Now if you notice here, that's a particular way of writing our match command. So we're starting off the child node using the children relationship, the children edge, to get back to the parent node. And again, we can actually write the same query but in a slightly different order to give us the same set of results. So what we're selecting here this time, so our first column is going to be the parent. Our second column is the actual parents relation. So on the first example, we use the children. This one time we're actually using the parents edge table. And again, we're going to query the relation out of that. And we're going to be calling the child name from the child table. So this makes sense. Our from clause is people, alias is child. And this time we're using the parents edge table. And again, we're using people and we've aliased it as parent. And the match is parent, using the parents relation, or parents edge relationship to find the child. So if I run that, similar to our results we had earlier. So basically what we're saying, parent Debbie is the relation is mother to child Rob, Tina and Jane, and Bert, the relation is the father to the child is Rob, Tina and Jane. So hopefully that'll make sense of the two edge tables that we've just populated there, the edges being children and parents. So I'm going to move on quickly and populate another edge table. So this time it's a table called siblings, and I'll put in a few rows of data here. So our siblings table is basically similar to what we had earlier. We're inserting into siblings. The from node is basically one of the people in the person table, and then the to node is a corresponding person, and then this time we're saying whether they're a brother or a sister, i.e. their sibling data. So here's the query to query that back, which I've just ran there, and I'll explain it to you. So effectively what we're saying is name Rob, the relation from the edge table is brother, and then the name from the people table again is Tina. So the actual query behind that is we're selecting from the tables, we're using again the people table, and we've aliased it as person 1. The siblings edge table that we have just populated here. And then again we're using the people table and we've aliased it as as person 2. So our match clause this time looks as so we're taking person 1 and we're going to almost if you're familiar with the idea of a cross join, so we're basically going to join the person 1 to the siblings edge table, so the siblings edge relationship link table, and we want to find out who the person is in terms of that match clause. And as you can see, that's basically what it says down here. You want to find out who person 2 is in terms of a sibling relationship. So hopefully that makes sense. So here's the data again. So name, so Rob is the brother of Tina, and he's also a brother of Jane. Tina is the sister of Rob. Tina's the sister of Jane. Jane's the sister of Rob, and Jane is also the sister of Tina. So as you can see, using In this sample set of data, we have only two node tables, but we have multiple edge tables where each edge table is basically defining a particular relationship, whether they're children, whether they're parents, whether they're siblings, and so on and so forth. So what I'm now going to do here is show you different ways that we can use the SQL to build up our different ways of querying our graph data, if that makes sense. So in the first sample here, I'm just going to include a couple of extra columns. So these are samples that we've already ran through. So as you can see here, I've just run this little bit of SQL query, and I've included the IDs. So I'm including the IDs so to familiarize yourself with the data that we inserted into the base node or the base edge tables. So again, what we're saying here is the match clause here. So we have a people table we call family member. We have a edge table, which is the children one we populated earlier. And we have the people table, but as you can see, I've not aliased that this time. So in terms of our match clause, we're saying the family member, and we want to link that via the children edge table to determine the actual person itself. So as I said, when we run that, the results that gives us our person ID 2, which in this case is Rob. So family member 1 is a son of person ID 0. Remember, 0 is Debbie, and person ID 1 is Bert. So basically we're saying Rob is a son of Debbie, Tina is a daughter, Jane's also a daughter of Debbie, and Rob is a son of Bert, and Tina and Jane are both daughters of Bert also. Now what I'll do here is got the same query but in a slightly different order, and what I mean by that is if you notice here the match clause is traversing or basically cross-joining our data on a left to right basis, which is indicated by the direction here. So basically we're saying take our node table, take our edge table to determine what the relationship is in this node table. But as you can see here on this example, the same example, but the match clause is in reverse order. So what I'm basically saying here is use again the people table via the children edge table to determine the relationship into family member. So if I run this query, basically as you can see here it gives this set of data, and what I'm going to do is I'll just open this up and we'll run both sets of data side by side. So you can see the difference there. So basically all we're doing is literally presenting the table in a different order depending on how you want to join your node tables to node tables via the edge relationship table. So I'm going to move on now, and I'm basically also going to show you the idea, as I mentioned earlier, that we're using standard SQL syntax, which has the match command also added in specific to graph databases. So as a result of that, we can actually union two select queries where the two select queries both have respective match commands, as you can see here. So whereas earlier I ran both sets of data as two separate queries, here I'm using a union all to then start to build up a larger set of data in the background. So basically all I've done here is I've added these two queries you can see here, and I'm actually running them in one execution block there using a union all to give me the set of data here. And as you can see, that's basically the same results, but it's one execution, one set of data. And again, to emphasize the point, it's just standard SQL. What I've actually done is I've then created a view. So I have the same query, but I've then actually made this a view. So the union all query we have here, I've simply added that into a view which I've called VW Family Graph Union. So I'll run that in here. There we go. And just to show you, I'll then select back from the view itself. So I'm selecting from the view rather than writing an individual SQL command with a match clause. And there you go. See, as you can see, I'm using the same results. Now, the reason why I'm showing you this is, as you mentioned, if you recall at the start of the video, I said we're also going to be using Power BI to graphically show our data rather than just running various SQL commands to query or analyze our data. However, there's one constraint when you use the Power BI to perform that role. The way graph has also been implemented in SQL, if you remember, as I mentioned earlier on, it's a little bit like replication, whereby replication uses when you turn a table into an article in terms of a replication publication within SQL Server. Basically, all that happens in the background is SQL Server adds on a set of unique identifiers which allows the replication to process. And graph is a little bit similar. And what I mean by that is, so let's take, for example, our people table. And if I actually open up and look at the columns inside of there, you'll see that there's an extra column being shown here. So if I just scroll back to the top of the screen, so when I was populating the people table, I was just inserting into person ID, name, and email. So here we have person, name, and email. But as you can see, we also have this $node ID, and we have this graph ID column. The $node ID is how the graph joins work. So if you remember, when I was inserting into the link tables, I refer to that $node ID. However, we also have this graph ID column in the background, and that's basically what SQL Server uses to manage the graph databases. And that column isn't accessible via Power BI. So the way you get around that is you create a view onto your graph tables, your graph nodes, and your graph edges, if you then want to subsequently visualize that via Power BI. So as you can see, when we're running queries here, we don't have to exclude those columns. We literally, standard SQL, you just type in the column name that you want to query, but for Power BI we can't do that. I'll touch on this momentarily, and we'll come back to this shortly also. So the next thing I wanted to show you in terms of SQL is, so you've seen match commands where we have basically a node mapping via an edge table to then determine the relationship into another node table. Similarly with match, you can actually then start to concatenate these. So you can concatenate edge relationships. Basically, let's just explain what that means. So I've got an example here where you have a match clause, but as you can see, I've actually got a concatenated series of calls going on here. So basically, let's talk our way through this. So we have our family member. So our from, we have the people table again, which we've aliased as family member. We have the parents edge relationship table. Then we have the people table again, which we're not aliasing, we're just calling it people. I then have the siblings edge relationship table, and again I have the people table again, and I've called it sibling itself, aliased it as sibling. So in terms of our match clause, what that's translating to is what we're saying here is we're taking our family member, so we're taking the people, and we're using the parents edge table to derive who is the parent of the family member. And when we've got that point, you can then see I then take those results and then saying, once we have that, use the siblings edge table to determine the sibling relationship. So let me run that so you can see a representation, and we'll then talk our way through it also. So as you can see here, we're saying family member Debbie, family relationship mother, child Rob, sibling relationship is the brother of sibling Tina. And hopefully that will make sense. So referring back to our match command, so match family member, in this case that row 1 of data you can see at the bottom screen is Debbie, using the parents edge relationship, so mother, to derive the person is Rob. So Debbie is the mother, so the parents edge of, in this case, Rob. And then we're then saying, so Rob using the siblings edge table. So it's a brother, and who is the actual sibling? So sibling is the people table. That's just an alias against that. And the sibling is Tina. And then as you can see, that data then repeats out through the various other relationships. So Bert is the father of Rob, Debbie's the mother of Rob, but Rob is also the brother of Jane. Tina's the sister of Rob, Tina's the sister of Jane. And as you can see, you've got various combinations of the family relationships. So as you can see, you can slowly start to build up views depending on how rich your data is on the background. You can start to build up view representations of your data. So what I'm going to show you here is I'm also going to show you, effectively I've been just selecting the absolute property columns. So what I've done here is I've reworked the same view, so the VW family join view, to also include, as we just mentioned here, to show that you can query the $node identity inside your views, but you can't, as I mentioned, query that graph ID column. So I've reworked the same view to include those columns I just mentioned. So if I run that view and then select from it, as you can see, we've also selected the $node ID columns in this case. I'm showing them here. So just to show you that you can access those via SQL. And again, to put that into context, so this is our people table, and I'll show you the address table, and again the columns are the same there. So you have this standard graph ID column, so that's 2 node tables. We'll open up an edge, and again you see the edge table, we actually have a few more columns. So effectively the edge again has the graph ID, and again it has a couple of more ID unique identifier based columns that it uses to hold the relationships between the nodes. So remember, the children is an edge table where it's showing the child relationship between the people node tables. So inside here we effectively would query the edge ID and the from ID and the to ID, so the relationships. So the from node, the edge node itself, the relationship, and the to node, i.e. the to node table and the actual relationship in itself. We've given this as children, so in that case this would be son, daughter, for example. So moving back over to here, what I'm going to show you is one of our other edge tables, and this is specific to the address. And the reason I'm showing this is we're just going to jump over momentarily and represent this via Power BI. So again, just to cover it over, so we're all familiar with that. Here's our match clause. So the from tables are the people table. Again, we're aliasing that as family member. This time we're using the home address edge table. And then we're actually using the address node table itself. And our match clause, as you can see here, we're mapping from right to left. So we're mapping the address via the home address edge table back to the family member. So we'll basically just run that. This is what we have. So we're basically saying the family member, so Jane, remember we populated this at the start of the demonstration, owns flat. The address is my flat, and then the actual one of the other properties there is the postcode, and that translates to this select clause we have here. And then one more match clause, again, sorry, one more select, which has got a concatenated match. I'll run that through and then I'll walk you through the data. So here, as you can see, we've got a concatenated match, but it's actually bidirectional. So we're doing a from relationship, so a from node relationship edge to a node, and we are then subsequently taking that node from via the siblings edge relationship to determine the sibling. But you can see here we then have another mapping going on here. So we're also taking the address via the home address edge relationship back to the sibling. So let me explain that in terms of the actual data, just show you that these concatenated match clauses can actually start to get quite powerful. So basically what we're saying here is family member is in the first row data is Debbie, via the parents edge table is the mother, two people. So in this case, so Debbie is the mother of Rob. And we then take that, I'm using the siblings edge relationship to sibling the way we did earlier. So Rob is the brother, sibling relationship to the sibling, in this case is Tina. And if you remember then we also had another mapping going on. So we were taking the address by the home address relationship back to Tina. And what that translates to, we were taking the address. So here's the home postcode, that's the actual value that we selected. So the home postcode RG1 lives at is the relation Tina. So Tina lives at RG1. And then just to put that into context again, to work our way through some of the rest of the data. So if you remember earlier on in our demonstration, we said Jane owns the flat, for example. And if you also remember, if I just find him in here, we also spotted that some of the other children lived at that particular address. So I'm going to leave the family data there. We spent quite a bit of time on that, and I'm going to jump over to the TFL data, and then we'll take both sets of data and we'll jump into Power BI. So our TFL data is on this tab. I'm not going to run through all that because it will turn into quite a lengthy video, but just to put it into context, so we have two node tables this time. So we have station, and I've got approximately 21 stations, and we have 5 tube lines. There's only one edge table here, and I've called it stops, and it's got 36 stops in it. Just to give you an idea of the data, so this is our line node table. So I've got a sample here. I've got Northern Line Bank Branch, Northern Line Charing Cross, Piccadilly District, Victoria. And I have then some, just to give you an idea, some additional properties inside that node. So I have, in terms of the table structure, I have a line ID and the name, then have the number of stops. So for example, Northern Bank has 50 stops. Attribute 1 is just a generic Wikipedia attribute. So Northern Line Bank was the first electrified traction line. Piccadilly suffered from the 2005 terrorist attack, and they also have a built property as well. So the year the line was built, for example, 1890, again back to Northern Bank. So to show you can have multiple properties in addition to whatever your main node data is, and the same on the relationship. So moving on, so basically here's our station table. So as I mentioned, there's approximately 21 stations. So I've got a sample of stations for each of our lines. So here you have District and Piccadilly, where there's an intersection between some of the other lines that we have in our subset of the London Underground data. And again, wanted to show you here, so we can have some additional property columns. So in this case, on our stations, we have some additional properties. So we have the station ID and the station name itself, but I've also added in some generic columns there. One's called, does it have lift access? So for example, yes or unknown or no, and also what the postcode is. So for Richmond Station, it has lift access, and this is its postcode. So again, to show you that your graph tables can have a number of additional property columns. And then, as I mentioned, we also have, I'll just touch on that, the edge table, which is down here. And our edge table is basically the link between the station and the line. So similar to our family data, just to give you one example here. So we're basically saying line ID 5 has a link between station ID 17 and its stop. So basically what we're saying there is for line ID 5 will stop at station 17. jump back up to our data. So line ID 5 is Victoria, and that will be stopping. So the Victoria line stops at station ID 17, which in this case is Stockwell. So what I'm going to do is, as I mentioned, I'm going to jump over to Power BI, and we'll do the family data first. So here we have Power BI, and as I mentioned, if you recall, that we're using a custom visualization which is called Force Graph. And basically you can download a number of custom visualizations into Power BI. The one we're using in particular, and the one I have here just to show you, is, so you take the file menu, and then we want to import. So you can go either to the custom visualization marketplace, as it says there, or in this case I've actually already been to the marketplace and I've downloaded my visualization, and here it is. Here it's called Force Graph, and that's the particular version of the Force Graph visualization that I happen to be using for this demo. I already loaded it here, so I'll cancel back out, but I just wanted to show you how simplistic it is to load a custom visualization into Power BI. And basically that Force Graph is over here. You can see it's got the little yellow box around it, and it's Force Directed Graph is actually the visualization name itself. So all I have here is a standard Power BI desktop, and I've taken one of those controls. I've taken the Force Directed Graph visualization, and basically what I've done is, this isn't Power BI tutorial, so I won't be showing you how to add, how to connect to your data sources. That's one of the prerequisites of having a basic understanding of Power BI. But what I will show you here is some of the views that I have brought in from the family data. So basically all I've done is I've created a view which corresponds to, let's give some more space so these are more apparent here. There we go. So as you can see, I've created a view for each of the either node or edge tables that I wish to query. And again, to put it into context, as you can see, so for example, the view address, I have the $node ID column, and then the address ID and postcode. So I will jump back to SQL, so that makes sense. So we've got a view, I've got an address, and there are the columns: node, address ID, address, and postcode. But if we actually look at the address table itself in the graph database, as you can see, we also have this graph ID column that I have excluded from Power BI, because Power BI, if you try to access those, you will actually get an error. So create the view and exclude those columns. And again, just to show you, here's our main people. I'll do it for a relationship, actually, an edge table to show you the difference. So here we have an edge table for home address. You remember the home address edge table, so I've called it VW edge home address. Jump back to SQL. And again, you can see the columns that I have excluded to allow Power BI to work. Right, so there we go. So basically, I have excluded the graph from ID, to object, and two IDs from our people. From our home address edge here. So I just have the $ID columns to allow the custom visualization to perform those mappings. So let's start off with this then. So as basically the way this tool works is similar to the match command itself. So you have a source, which is the from node, a target, which is your to node, and then you have So sorry about that. So let's pick up where I left off there. So basically, what we're going to do here is, effectively, as I was just describing, the way the Force Direct Graph visualization works is similar to the match command. So we have the source, which is our from node. So as you can see here, what I've added in is from the view people. So from the people node table, I've added in the name. And then I actually want to determine the postcode, so that lives in address, so we'll use the address node. So via this view we'll add in postcode, and what you'll see is force direct basically adds that second column into the target. So the source is the from node and the target is the to node. And because I've already included the relationships here in my data, as you can see, basically Power BI has actually drawn those relationships already. But so this demonstration corresponds with a match command, I'll also include the relationship. So remember, just jump back through to give you an example. Remember, in terms of our family data, on our match commands, we had the from node via a relationship, via an edge table, and we were then cross-applying that into another node table, in this case to determine the parent. So back in Power BI, we have the same principle. So we need to add in the relationship. So in this case, it's the home address. So we'll add it in there. And basically, the reason I've done that is, as you can see, we have let's run through this again. We have the people name, the address, postcode, and then the relationship between those is the home address edge table. So visually, the way this represents is, so for example, we'll take Debbie. So Debbie relationship lives at, so the Debbie node, from node, relationship to map into the address node. So from to via the relationship, Debbie lives at that postcode. And as you can see here, that repeats. The commonality here is the people who are residing at the RG1 postcode. Where Bert, if you remember, owns it, whereas Rob, Tina and Debbie live at it. And again over here, you can see we have Jane. So Jane owns the flat, if you recall, and the flat is basically RG11. So what we can start to do then is we can start to use Power BI to graphically query our tool rather than writing a number of SQL select clauses via the match command. So what we'll do is we're going to use the same three values just to show you what that translates to. So we'll keep the people name. This time we'll actually put the relationship as our target, and we'll put the address postcode as the link type. So again, we've got the same data but a slightly different representation of it here. So what have we got? So basically what we're saying is Jane for this postcode is the owner, Bert for this postcode is the owner, but Tina, Debbie and Rob for this postcode are lives at. So again, you can see using the custom control, there's different ways of querying the same data, or there's different ways of graphically representing the same data set. So what I'll also do is, remember in the demonstration we created views, where the views were an amalgamation or a concatenation of a number of different joins. So what we'll do is, to show you that, I'll add those in here. So this time I'll add child in as my source, and I'll remove name because that's no longer applicable here. We're going to make the target the sibling, and we'll make the link type the sibling relationship. So basically, remember from SQL, this is a graphical representation of a query we did earlier. So for example, as you can see, the edge has a directional arrow on it. So we're saying Jane is a sister of Rob, but Rob is a brother of Jane. And then we have the equivalent relationships here, where we're saying Jane is a sister of Tina, and Tina is a sister of Jane, and then finally we also have Rob is a brother of Tina, and Tina is a sister of Rob. And what you can also notice is using some of there's an awful lot of properties that you can set in this visualization to enhance your graphical representation of the data. So as you can see here, I've also added color coding, where I have this aqua turquoisey color for the sister relationship, and I have straight a black grey line for the brother relationship. So we'll change this a little bit further. So this time we'll make the family member our source. Take out child, and we'll actually make target child the child the target this time, and our link, our relationship, will be family. So just try to make that a little bit more easy to read. There we go. So what we're saying here is, so our source, so our from, is the family member, and we want to determine the child relationships via the family relation edge. And the way that looks graphically is, what we're saying here is we're saying Debbie is the mother of Jane, she's also the mother of Tina, and she's the mother of Rob. Bert is the father of Jane, Tina, and Rob. And again, you can see using this idea of color. So in this case, the aqua is referring to the father relationship and the black is referring to the mother relationship. So that's quite a nice way of giving you a quick demonstration of how you can query your data via views onto your node and edge tables inside a SQL Server Graph database, or as we saw during the first part of this video, you can actually write the SQL commands using the match command and just directly query your data via a query window. So again, we have one more set of data which I'll show you, and this is our TFL, so the same principle. Got another Power BI desktop here, the custom visual is already loaded. And again, I have 3 views. Remember, for the TFL data, I'll make this more clear, it's a bit squashed. So the TFL, we had 2 node tables. We had line and station, and our stops is the relationship between the two. So basically what I'll do is I'll very quickly add this in. So we'll make the line, we'll take the name of the line as our from. We want to make our target the station name, which is here, and we'll make the actual relationship the stops. So as you can see, bear in mind, if you remember, this is a subset of the data, so it's not the full, but you can see it actually starts to get quite complicated. So if you had the full London Underground here, you'd actually have a very complicated graph to read. So if you remember, we had a small subset of lines in here. So we've got Northern, Victoria, Piccadilly District. So sorry, that was Northern Charing Cross, and we have Northern Bank down here. And as you notice, as I highlight each one, it's showing the relationship between the line and the subset of stations that I have for that line. And here is for Victoria again. Now, to give you an idea of how you can use Power BI to dynamically query your data, you might actually say, okay, so for example, let's find Euston Station. So here's Euston stop. So this is Euston stop itself. And basically, as you can see here, it actually calls at 3 lines. So Northern Bank, Northern Charing Cross, and Victoria. But you actually might want to look at Euston itself. So what you can do is you can start to apply filters on top of your data set. So what I'm going to do is I'm going to filter the lines down to the 2 northern ones, Bank and Charing Cross, just to try to make that large set of data easier to view. So as you can see here, basically there's our data, but you notice Euston, for example, in this case only has 2 lines. So the Euston station only has 2 lines on this graphical representation on this graph here, which is Northern Charing Cross and Northern Bank, and that's because we've filtered specific to those 2 lines. When we want to query that further, so we actually might want to check that that's correct or it's valid, we might actually want to filter the station name specifically. So we can pull out Euston and then remove our line filter, and instantly you can see there it's basically saying, well, Euston actually has 3 lines attached to it. So Northern Bank, Victoria, and Charing Cross, which is that's a quick summary of Power BI itself. Now, jumping back into the presentation, one thing I do need to point out is, as I mentioned at the start, the graph implementation currently is the first implementation, and as a result of that there are some limitations. So the limitations are one graph is supported per database. So if you recall, we've got the SQL Graph database held the family data, and SQL Graph TFL held the London Underground data. We don't have support for polymorphism. To reduce that, make this simplistic. Basically, it means there's no functionality to find any node related to my node. So in the context of the TFL data, what that means is, let's query all the data. As you can see here, if I was at particular to, let's say, Hammersmith, and we had the full tube underground data in here, we'd say, well, actually, Hammersmith isn't showing the circle line, for example. And basically, what we're saying is polymorphism. You can only show the relationship between two nodes. You can actually only query between two nodes, if that makes sense. And this also applies. This also applies to transitive closure is not supported. And what does that mean? Basically, it means the mapping of all possible paths between two vertices or nodes. So again, we're basically saying if we wanted to get between station A and station C, it won't show us all the paths that are possible, so all the different lines we can use to get between those two stations. So that is supported in Gremlin. It's currently not supported in SQL. So contextually, what that means is SQL only supports unidirectional mapping, so you can only map from one node via relationship to another node. Similarly, update on edge columns is not allowed. So if you want to update your edges, the only way to actually do it is to remove that edge record and reinsert it. In terms of SQL Server itself, if you're familiar with that, there's no support for in-memory OLTP objects. Sorry, it's limited. There is support for it, but it's not the full support. And I'll jump ahead again. So table types, table variables are not declared as node or edge. A couple of more limitations, which is probably quite an important one, and hopefully that will be implemented shortly. There are various functions inside the Gremlin language, and the one we don't have here is shortest path. So basically, shortest path is between, again, as an example, two stations, station A and station C. It might be possible to get to station C by taking a particular route, which meant you had to change tube lines a smaller number of times. You can't do that analysis currently within the SQL Graph limitation. So basically, that's it. That's a quick demonstration of the SQL Graph implementation. And I've included some links in here for you to do your own analysis. So we have the SQL 2017 graph. That link there will give you an explanation of how it's been implemented. The custom visualization you can actually download from that link there. However, if you go into Power BI, as you could see from my menu option, one of the import options is from the marketplace. There's a GitHub link here which I will be populating with files to allow you to run through these workshops yourself. And also similarly here, contact me. I'm always happy to help. So Twitter is _Neil Millington. And there's a LinkedIn profile again there, so message me or get in contact if you need help. So linkedin.com Neil Millington. Thank you for your time, and hopefully you will look at some more of my videos. Thank you now. Bye bye.